It started out with graphene and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3.
Alright, here's the introductory variable for D0, and it tells us without graphing. Okay, so I'm going to cheat and I'm just going to show you a bunch of graphs, okay? And I'm actually going to look up back at C. And I want to note all of those that were failed. Okay. If you look at this one is an even because the arrows are both in the same direction. So even, it failed. This one is also even over here. That one failed. This one has arrows in the same direction. They're both facing up. This is an even. It failed. Okay. And oh, look at this one. Direction. So this is an odd degree, so that one passed. That's why I have green. Same thing in the C3. Arrows are in opposite directions. It's an odd degree, and it passed the horizontal line test. And this one's also an odd degree, and it also passed. So let's write that conclusion down. Passed the horizontal line test, which means it's invertible. But the ones that failed were the even degrees. It failed the horizontal line test, which means it's not invertible. Okay, now I show you guys now without a graph. Okay, let's take an even degree, such as this graph. X squared isn't even that number. Now, within this, if you put in -2 for x, you will get 4. And if you put -1, you get 1. 0, you get 0. Put 1 in there, you get 1 squared is 1, and then 2 squared is 4. Okay, you cannot take the inverse is right here. Do you see the repeating y values? The repeating y values will eventually tell you that it's not 1-to-1. Once we take the inverse. Why? Is because the inverse basically means to switch the x's and y's. This. If I switch these and all the numbers 4, 1, 0, 1, 4, you'll have -2, -1, 0, 1, and 2. And we did that trick where you basically rotate it left, and then you would flip it over the y-axis. So if you look at this graph here, you would try to take the inverse of that one. And it's not pretty, but you would have to do something like restricting the domain in the original graph. Okay, kind of complicated, but let's try this one. We use x to the first. And if I do the what color have I not used over here? Let's use green. Okay, if I rotate, let's take this one. If I rotate it 90 degrees to the left, it's going to look like this. And then if I reflect over the y-axis, it's actually why that one happens is because inverses reflect over y equals x. And you can see this in the coordinates 0, 0, 1, 1, 2, 2. You'll realize that once you take the inverse, there's no repeating values in the y. So in this case, it is 1-to-1. It is a function, and then when you take the horizontal line test, if it's an odd degree, it's invertible. But if it's an even degree, then you can't do it. All right, for D1, we just need to figure out without graphing Determine whether or not each function is invertible. Well, all you have to do is just locate the degree. There's the degree of the polynomial. Is that an even or odd? 2 is an even number. Evens are not invertible. So let's write not invertible. Because I explained in the introductory video that it's not one-to-one. Alright, D2, we're going to, without graphing, determine whether or not each function is invertible. So we're just going to find, we're just going to locate the degree. It's an even degree. So back in our intro video, we said it's not invertible. And you could visualize it, but just think about it. Even degree is going to look like this. It's going to pass the vertical line test right there, right? Only goes in one place, but it will fail the horizontal line test. Does that make sense why? All right, D3, without graphing, we need to determine whether or not each function is invertible. We just need to first locate the degree. The degree here is an odd, and odds are invertible. Remember, we're not supposed to, but we can. If you actually graph this, this is an odd. So normally it would be graphed like something like this, right? The arrows are in different directions. And because of the negative, it's going to flip it. And basically what's going to happen is that it passes the vertical line test, so it is a function, and it also passes the vertical line test, horizontal line test, which tells you that you can take the inverse. All right, in this problem, D4, we need to determine if, without graphing, if this is invertible. So we're just going to locate the degree. And the degree here is a 10, and 10 is a even. But we said in our intro video that even degrees are not invertible. Get another explanation, not only in the intro video about not being one-to-one. If you just did a quick graph of this, even degrees start up, end up. This one has a leading coefficient that is positive, right? 1.257 is positive, so they start there. And you'll notice that it passes the vertical line test. So that means it is a function. But if I do the horizontal line test, it goes through more than one point. So that means on the horizontal line test, it fails. That means that it's non-invertible. This one fails. Okay? All right, D5, we are asked to, without graphing, determine whether or not each function is invertible. So the first thing I'm going to do is go ahead and locate the degree of D5. That's a small number to the top right. This number is an odd, right? Cannot be divided by 2. I have a remainder of 0. And we already noted in the introductory video that odds do pass the horizontal line test, so it is invertible. Remember, to prove that one, you can just draw a graph. The easiest odd we know is just like a linear. And if I use in here in yellow, this one will pass the vertical line test, and this one will also pass the horizontal line test. That's why it is invertible. We're not supposed to do it by graph, but I just wanted to show you. All right, D6 here. In skills practice 3.11, D, without graphing, determine whether or not each function is invertible. So the first thing we're going to do is we're going to locate the degree. And this degree here is a small number to the top right. It's called an exponent or a degree. And 124, that number is even. And we did in the intro video that evens failed the horizontal line test, therefore it's not invertible. So that's the answer. Not invertible. Now we're not supposed to do it by graphing, but I do want to show you a visual. If you graph this, evens, the easiest even we know is x squared. But this one has a negative, so it's going to be going down. It's not really going to change it because if you, on the blue, if you take the vertical line test, it passes, which means it's a function. It already told us that. But if I use the horizontal line test, it will fail because it goes through the one point, then it won't be 1 to 1. So D6 is not invertible.
It started out with graphing and then it went to functions. I'm doing FOIL to solve x. Next is the expressions. Now I have to see if x is equal to or greater than 3. Now you make that point on the x-axis. Wait, was it a positive 3 or a negative 3?